This question from March 16th, 2025, Quiz 2 question paper, deep learning. Consider a loss function L of W, that is loss function in terms of W cube plus 2W, where W represents the model parameter. The Adagrad optimizer is used to minimize the loss. So the Adagrad optimizer is used to minimize the loss. This is the loss function. The learning rate eta is set to 0.5 and the initial iterations t equals to 0 and the parameter w has starting value of initial value is w not equals to 2. So the Adagrad update rule. So in this question is very simple. This question is very simple. Only substitution of the values, the above values is enough. Careful about the calculations. And related to Adagrad optimizer. So what is an Adagrad optimizer? It adapts the learning rate. What it adapts? It adapts the learning rate eta. That is learning rate eta for each parameter individually using past gradients. So Adagrad, in this question the Adagrad optimizer is used to minimize the loss function. So generally Adagrad is an optimizer. Name also, Ada means adapts the, what it adapts? The learning rate for each parameter individually by using the past gradients. What are past gradients? This delta wt square is gradient means partial derivative, right? Partial derivative, that is dou by dou w, dou L by dou w, loss. So this is the past gradient. Adagrad update rule, that is wt plus 1. Here t is very important. T is the time step. So at the time step t plus 1 equals to wt minus eta times, this is the learning rate, square root of vt plus epsilon times delta wt. So this delta wt is the current gradient. Current learning rate. Eta is the learning rate, everyone knows. Next, epsilon is the small value. Why we required epsilon? If square root of vt, that is denominator, becomes 0, this value becomes 0, division error will come, right? To avoid this, we add small epsilon value. Sometimes epsilon value is 0. In this question they mentioned epsilon value is 0. It's small value is important. Vt is the sum of the squared gradient. Vt is sum of squared gradients. Sum of the squared gradients. This Vt is very important. How do we calculate Vt? So using this above formula. So Vt equals to Vt minus 1, that is its past value, sum of the squared gradients to 1 is, so it is mainly used for sparse data. Sparse data means more number of zeros. Zeros are more when compared to number of ones. Adagrad uses the past gradient. It uses the past gradients. Eta decreases. At the learning rate, eta decreases over time. Adopts the learning rate means it changes the learning rate. Adopts the learning rate for each parameters individually by using the past gradients, right? It changes the learning rate. There are two types of parameters: more frequently updated, less frequently updated parameters, right? less updates for the large learning rate parameters. If the learning rate eta is small, which parameters have learning rate is small, it more frequently update the parameters. More frequently update the parameters. Which parameters have the large learning rate, that parameters are less frequently updated. And more, if the learning rate is smaller, and more updates for that parameters. Okay. L of W equals to, mention W cube plus 2W. W cube plus 2. So given in the question 0.5 eta, and at the initial iteration t equals to 0, W naught equals to 2. So at initial iteration t equals to 0, at that time W naught initial weight value equals to 2. So what will be the value of the parameter W after the first iteration? That is, so after the first iteration they are asking to find W1. How do we find W1? W1 means at t equals to 1. Relation Wt plus 1 equals to Wt minus eta times square root of Vt plus epsilon 0, right? 0 times delta Wt. Delta Wt. In this relation they are asking W1. That is, W1 means t equals to 0 plus 1. That is W t equals to 0, right? W naught minus eta equals to 0.5 by square root of V t equals to 0. V naught times delta W naught. T equals to 0, not t equals to 1. 0 is the correct. So that is t equals to 0, W naught equals to 2. That is 2 minus 0.5 by square root of V naught times delta W naught. We want to find delta W naught, that is the gradient at t equals to 0. Partial derivative of loss, that is dou L by dou W at t equals to 0. That is, this is the loss function, right? That is 3w square plus 2 at t equals to 0. That is 3 times 2 square plus 2. That is 3 times 4 plus 2. That is 12, 14. This value is 14. So this value equals to 14. So we want to find V now. Vt equals to this relation. Vt equals to Vt minus 1 plus delta Wt square. So Vt equals to Vt minus 1 plus delta Wt whole square. We want V naught, that is at t equals to 0. That is V naught equals to V minus 1 plus delta W naught whole square. That is V minus 1 equals to 0. So in this values, V minus 1 0. That is delta W naught whole square, V naught equals to, that is 14 square. Its value is 196. 14 square is 196. So we want to find W1. W1 equals to 2 minus 0.5 divided by square root of 14 square times 14. Both are cancelled. 2 minus 0.5, that equals to 1.5 is W1. So the answer for this question is 1.5 in this range. Is this correct? we find what are values. Delta W naught equals to 14. Okay, W1 equals to 1.5. W naught equals to given 2 and V naught equals to 14 square. You can remember these values, use for next question. Continuation. So friends, continuation of the above question is, what will be the value of the accumulated sum of the squared gradients V after the first iteration? In this formula, Wt plus 1 equals to Wt minus eta is learning rate. Vt is the accumulated sum of the gradients. Accumulated sum of the gradients. This is Vt. So they are asking to find the value of V1. So V1. So using this equation V1 that is at t equals to 1. V1 at t equals to 1, that is equals to V1 minus 1 plus delta W1 whole square, that is t equals to 1, that is V0 plus delta W1 whole square. V1 equals to, so delta W1 equals to, that is the gradient of the loss function, dou L by dou W equals to, this is the loss function, right, equals to 3W square plus 2. Calculated in the previous question, V naught equals to 14 square. So V naught equals to 14 square, that is V1 equals to 14 square plus delta W1 whole square. So we want to find delta W1 calculated in the previous question. So this is W1 equals to 1. Is W1 equals to 1.5. V naught equals to W naught square. Calculated from these two values are calculated from previous question. Delta W1 equals to dou L by dou W at W1 equals to 1.5 equals to 3 times W1 equals to 1.5 whole square plus 2. Use 3 times 1.5 whole square is 2.25 plus 2. So delta W1 equals to 3 times W1 square plus 2. Okay. So and this value is 8.75. So V1 equals to 14 square plus 8.75 whole square. So in this equation, right, that is 14 square is 196 plus 8.76.5625 and it is 272.5625. This is the V1, 272.5 and W naught equals to 2 at t equals to 0 and eta equals to 0.5. We already calculated W1 equals to 1.5 and V naught equals to 14 square. Can remember this value. And delta W1 equals to 8.75. These are useful for the next question. Is in this range. Okay, this is the correct answer. So what will be the value of the gradient W after the first iteration? That is delta W1 at t equals to 1. We already calculated 8.75, right? 8.75. This one 75 in this range. So the answer for this question is correct. The answer for this question is correct. And for the next question, what will be the value of the fourth question? What will be the value of the parameter w after the second iteration? That is w2 they are asking. So using this formula we calculate. It is easy. w2 we want, that is 2 means w t equals to 1 plus 1. Okay, minus eta times square root of v, t equals to 1, right? T equals to 1 plus epsilon is 0 times delta w t1, t equals to 1, that is w2. This is w1. w2 equals to wt equals to 1 plus 1. This is w1. Sorry, this value is t equals to 1, right? w1, that is w1 minus eta equals to 0.5 divided by square root of v1 times delta w1. So w1 we already calculated in the previous question, 1.5. w1 is 1.5 minus 0.5 divided by square root of v1. v1 272.56, this value v1. So v1 272.562. We already calculated in the previous question, 272.5625 times delta w1 is 8.75, that equals to 1.5 minus 0.5 divided by square root of 172.5625 is 16.5095 times 8.75, that is w2 equals to 1.5 minus, its value is 0.03029 times 8.75, and w2 equals to 1.5 minus, if you are multiplying these two values, 0.2650, w2 equals to 1.235. Friends, this is the answer for this question. Thank you for watching. If you like my videos, please like and subscribe my channel.